In this lesson, we're going to be looking at perpendicular and angle bisectors. This is something we've done before. We've talked about bisectors. Remember, there's something that cuts something in half. So a perpendicular bisector is something that cuts a segment in half, and it's also perpendicular. It would be a line or a ray, something that cuts it in half, and it's perpendicular to that segment. And an angle bisector is, of course, when we cut an angle in half, when we make two equal angle measures inside. And then one of our new vocabulary words in this lesson is going to be equidistant. Equidistant is when it's going to be an equal distance from something. So say our midpoints, and a midpoint is equidistant from the two ends of a segment. So that'll be a familiar term we'll see in this chapter. So again, we've seen perpendicular bisectors before. We have two new theorems that come off of perpendicular bisectors. So our perpendicular bisector theorem just tells us that in a plane, if a point lies on the perpendicular bisector of the segment, then it is equidistant from the endpoints of the segment. So in this case, the length from A to C and the length from B to C is going to be equal. So if this one was 5, this one would be 5 as well. They're going to be exactly the same. So we could make marks on this diagram, so that would be 2 line and 2 line. Because we can see that the line that C is on is perpendicular, and this point of P in the middle is in the middle of that segment AB. Then we have the converse of the perpendicular bisector theorem, and it basically just says the opposite. It tells us that if a point is equidistant from the endpoints of the segment, then we can determine that it's on the perpendicular bisector. So given that we know that D has an equal distance from A and B, we can see that from our tick marks here, then we can determine, even though we don't see the line going all the way through D, we can know that D is on that perpendicular bisector. So just a few examples we have up here in example A. We can see that B is located in the middle between A and C because of our tick marks here. And we have our right angle telling us it's perpendicular. So if it's perpendicular, that means any points on that perpendicular bisector would be the same distance from A and from C. So no matter if I have a point somewhere in the middle, if I have a point way out here, they're going to be the equal distance from that A and C. So we can know that this point of D lies on our perpendicular bisector. It's going to be the same distance from A as it is from C. So if AD is 27, that means CD has to be 27. This next diagram, we have our right angle here on this Q, on this line that goes through Q. You can see that point S is the same distance from P and from R. So we can kind of do the opposite reasoning and be able to determine that since S is the same distance and it is perpendicular to that line of P and PR, then that would mean that they have to be the same length as well. So if these two were the same length, that would mean that P to Q and R to Q would be the same length as well. So that makes PR 5. Our last example of C has some algebra in there. Obviously, it has variables. So if we look at it, we know that this line of HF is perpendicular to the segment EG because we have our one line, we have our right angle. So that means these two have to be the same as well. That point H would be the same distance from E and from G. So if they're equal to each other, I can write them equal, and I'll be able to solve. So 2x is equal to 3x minus 8. To solve it, I'm going to add 8. Or actually, I'm not going to add 8. I'm sorry. Thinking of the wrong thing. I'm going to get my variables together, so I'm going to subtract this 3x to move it over with the other x. When I do that, I get negative x is equal to negative 8. I need to get rid of my negatives, so I'm going to divide by negative 1. So x is equal to positive 8. But if you notice, my problem didn't ask for x, it asked for GH. So GH is this length here of this 3x minus 8, so I'm going to plug it in, substitute, so I get 3 times 8 minus 8. So I get 24 minus 8, so I get 16. And this next problem asks us to determine if we have enough information to conclude that point N lies on the perpendicular bisector of KM. So this picture, it's a little bit hard to see. It just has a bridge. So our triangle, it has on there, it has K, it has this line here, it has L, and it has M. And then it tells us that these two are the same. It asks us to know, is point N on the perpendicular bisector of KM? Well, we can see that this line that goes through here, this line of LN, if I were to extend it to keep going, it is in the middle of KM, right? So if I had a point here, that point of L, point L is the midpoint. Okay, so it is a bisector of KM. But can we determine if it's perpendicular or not? In this picture, there's not enough information. N could be really far to the left. It could be really far to the right. It doesn't tell us that it's right there to make it perpendicular or not. We do not have enough information, so the answer to this would be no. The second part of our lesson is angle bisectors. Same thing, we've already gone over them before. We know an angle bisector cuts an angle exactly in half, but we have just some other theorems that go with it. So the first one, angle bisector theorem, it tells us if a point lies on the bisector of an angle, then it is equidistant from the two sides of the angle. So if I were to go straight there, in which when I go straight there, it's always going to be perpendicular. Remember, the shortest distance between a point and a line is always going to be that perpendicular line there. So if you see, if we're talking about point D, its shortest distance to that line of AB is going to be to go straight there and make that right angle. Okay, because otherwise, if it went off way off to the right, that's going to make a longer line, right? So the shortest distance is that perpendicular line. And so if we do the same thing to the other side, it's going to be of an equal distance, is what angle bisector theorem tells us. Then the converse just tells us the opposite. If a point is in the interior of an angle and it is an equidistance from both sides of the angle, then we can determine it lies on the bisector of the angle. So since we know in this case that D is the same distance from B as it is from C, both of them make right angles, then we know that D is on the angle bisector of A, and we would be able to add in that that those angles are the same on both sides. Be able to add those lines in. So in these examples, we can look at that. So for A, it asks us to find ABC. So ABC is going to be the total angle. Right now, we don't know whether or not it's a bisector or not. But if we look at it, point D, first of all, it makes a right angle when it draws it straight to this A on this side of the angle. And it makes a right angle on the other side going straight to C. So that means it's the shortest distance from D to that side would be that path. And that distance happens to be the same on both sides. So if it's the same on both sides, based on our converse, we know that it has to be on the bisector of the angle. If it's on the bisector of the angle, that means that these two angles have to be the same length on both sides. So if that one's 56, this one would also be 56. If I add them together, it would give me ABC, which is just 56 times 2, giving me a total of 112 degrees. If we look at B, we want to know what JM is, the length of it. If you notice in our diagram, we have that this is an angle bisector, because notice that one has one line, this one has one line, so that means those angles are the same. If they're the same, then that means that M, since it lies on that bisector, is the same distance from both sides of the angle as long as you draw that perpendicular line. So that makes these have to be the same length. So if they're the same, I can equal them out to each other. And then now I just have to solve. So to solve, I'm going to subtract my 2x. So I get 2x is equal to 12. divided by 2, and I get x is equal to 6. My problem didn't ask for x though, it asked for jm, so I have to substitute. 4 times 6 gives me 24. Just like usual, we'll continue to do examples in class and activities, so I encourage that you ask questions, make sure you're understanding the concepts. This chapter will be kind of shorter. We don't cover as much in this chapter, so your test is going to be coming up fast, so be sure you're staying up with everything you need to.